Alright guys, here we go. We have quite a review ahead of us. This is probably either going to be a couple long videos or one long video. We'll see how that works out. Number one, right and appropriate, simplified equation for finding the sum of exterior angles. Exterior angles of any shape equal 360. That's on your green formula chart on the back of the circles page. So what you see here is we combined like terms. You just add everything together. 8x, 6x, 6x. That gives you 20x. 60, 100, 120 gives you 180. And you add them up, set them equal to 360. Again, and I'll probably repeat this a lot throughout this video, it's multiple choice. So, look at your answer choices to see what exactly, what the answer is supposed to look like. All right? Number two, write the information that occurs starting from box 1 to 2 and then all the way through 4. So this is a reflection, it flipped over. This is a rotation because it rotated down. And then this is a translation. I guess in theory, if each box is the same thing, it went up, but it moved, right? It just moved left to right or whatever. All right, so there you go. Those are pretty easy. What is the value of x? Idea here that B and C are inscribed angles, and they both meet at the arc AD, so you set them equal. 6x minus 3 equals 7x minus 11. And then same thing on the opposite end, angle A and angle D are inscribed, and they meet at BC, so you set those equal to each other and solve for y. All right, and you solve at x equals 8, y equals 10, you see the work there. Pretty straightforward. Don't confuse these. The only thing I'll add in is don't confuse these with opposite angles or supplementary. That would be if there is a four-sided, a quadrilateral inside, it would look more something like that. But you have the crisscross in there so you can identify the individual angles, the inscribed ones. 4, find the difference of the surface area of the two spheres below. Surface area, of course, the formula on a blue chart. Just one of the little things as you're going through this test, make sure you recognize the difference between surface area and volume, and make sure not to use the wrong formula, because that, could be an easy mistake. Also, don't forget, if they give you the whole diameter, you need radius, which is half the circle. That's why we take 7.5 and 4.5. And they ask for difference, so 4 pi times 7.5 squared is 706.86. 4 pi times 4.5 squared is 254.47, and then you subtract them. 452.39. Number 5, special right triangles. Now we hit a section here of the review where we do a lot of special rights, and I know in general that some of you it never quite, clicks, or you still get a little confused about the way they set up. It's multiple choice, so don't forget, if you're better with trig, most of the time you can use trig to find missing things, if that helps you. But I am going to go through the review mostly those questions as they're intended to, but I'll mention when you can use other things. So here you want to find DF, which is right there, and FE, which is right there. So on the 45, 45, 90, on the left side you see the x squared of 2. That comes from the blue formula chart. It's just a pattern, right? Anytime you see a right triangle that's 45, 45, 90, that pattern will exist. The two legs will be congruent. The hypotenuse is that length times the square root of 2. Because the hypotenuse has a 5 square root of 2, that told us that the two legs are 5. That's the x, if you will. And that first off gave us df. And then on the right side, where you have the 30, 60, 90, this was x, hypotenuse was 2x, and then x square root of 3. So if the x is already 5, because it's the same side from the other triangle, then 2x gave us 10 at the hypotenuse, and more importantly, the leg we're looking for, FE, is 5 square root of 3. So again, that's just applying the special right formulas. You could go back and use trig if you really wanted, right? You had from this angle You could have started by doing opposite and hypotenuse, and solve that. Put 5 squared root of 2 as a decimal. But either way, okay. Number 6, a kite string is 220 feet from the kite to the ground. The string makes a 45-degree angle with the ground. About how high off the ground is the kite? So we've used the kite a few different times. Kite's in the air, you make your right triangle. The string is 220. Again, intended to be a special right with the 45, 45, 90. So you have x squared of 2. This time the hypotenuse doesn't have a square root with it. So you set it equal to 220, which you see there on the right. When you divide by 220, there is, when you have 220 and you divide it by the square root of 2, there is a longer algebraic process you can use to simplify that, to get the square root of 2 out of the bottom. Again, you do have a calculator, you do have multiple choice. So if you literally just divide it, and then depending on your answer choices, you can just match them. Because even if your answer choice looks like this, you can do 220 divided by the square root of 2, get a decimal, and then take your 4 answer choices and multiply them out to match, right? So the multiple choice definitely gives you some options to help you get to answers a little bit easier. Number 7, a building trades class built a circular spinner for a school carnival. It has a 48-inch diameter, 24 congruent sectors. What is the exact area of each sector? So we've had this problem a lot of times here, different times. 360 divided by 24 gives you the arc degree. The diameter is 48, so the radius is 24. So you're going to use arc length, area of a sector. On the back of the green chart, again, behind the circles, you have that formula. So arc degree over 360, 50 over 360, times pi times radius squared. I multiplied everything through. Again, if they don't multiply pi, if they keep it in terms of pi, you just, don't multiply pi in your calculator and match it on the answer choices, or multiply everything out and match. Either way, right? All right, so 1 page down, 6 more to go. All right, let's get going. All right, here we are on page 2. Give me just a quick second to set this up. All right. Which arc has a measure of 250 degrees? So the key really is to find the missing angles inside. That's the most part. CA and BD are diagonals, so they cut the circle in half to 360. Sorry, 180, not 360. They cut it in half, 360 to 180. So with this being a 70, 180 minus 70 gives you 110. On the top then, if you have 110, basically you work backwards again to get to 70, because it has to add to 180. On the bottom, underneath BD, 70 plus 50 is 120. 180 minus 120 is 60. So you find all the missing angles, and then 250, the way you get those, let's see, hold on. And then the way you kind of show it or figure it out is, like when they give you 3 letters, because if it's multiple choice, you'll probably have 3 letters for an arc. Like BAC that you see there, you start at A, you start at B, you have to go through A, and then all the way around till you get C. Well, that means you're adding up 70, 60, 50, 70, which is 250, right? So that's how they work, remember. And then there's a second choice here, and again, it's multiple choice, so only one of them will be there and work. But if you go A, B, D, start at A, go through B till you get to D. 70, 70, 110 also gives you 250. Excuse me. Number 9, find X. So this is not a quadrilateral GBIH, right? I mean, they connect, but it's not an actual parallelogram or anything. What you have is 2 separate angles, one informed inside at H, you could even really see that because I match the line, you have this inscribed angle at H. If you look on your green formula charts, I think it's like number 2 on the front, on the circle side, is inscribed angle. The angle is half the arc. Now be careful, make sure you understand this. The arc will be twice as big as the angle. So over here you see 58 times 2, that gives you 116 for the arc GI. The second angle formed here is the one formed outside the circle by these two tangent lines. All right, and that to get that, that's I think number 7 toward the bottom of the circles page. It's tangent, tangent. Excuse me. And it's major arc minus minor arc divided by 2. The major arc is the rest of the circle here, GHI. And the way you're going to find that is by doing 360 minus the 116 you found for GI. So once you do that, you get 244, and then the formula for number 7, 1/2 major arc minus minor arc, and you get 64. Number 10 is another special right triangle. Again, it's set up as a 30, 60, 90. You can also do trig. What you see there on the answer key is set up obviously a special right. You could do trig with opposite, hypotenuse, adjacent. You're looking for n, so you would use opposite and hypotenuse, which is sine. But again, either way, should get 20 there. Find the length of the diagonal of a square whose side is 9. Again, sets up as a 45, 45, 90. X squared root of 2. If every side is 9, then the hypotenuse should just be 9 squared root of 2, because that's the pattern. But again, this one you can actually use Pythagorean theorem because you have 2 sides. So multiple ways to get there. Number 12, you have an equilateral triangle with all sides being 8. You're looking for the altitude, which is the height. When you do that, when you drop a line down the middle, you create 2 30, 60, 90 right triangles inside the equilateral. And so with the bottom being 8, you cut that into 4 and 4. And then the hypotenuse is still 8. So here it's set up for a special right where you see x squared root of 3, which is what you're going to look for, and 2x. X is 4, so clearly, like you see as the answer, it's just 4 squared root of 3. But you could also do Pythagorean theorem, which you see over here, 4 squared plus b squared equals 8 squared. You could set up a trig problem. All of those work to get the same answer, 4 squared root of 3, or whatever decimal that would come out to. All right, let's see. And again, I'm going through some of these quicker because, like I said, there's a lot more problems on this review than the test. I hope if you go through this, then you get to the test and realize it's probably easier. And that's the hope, to make it for you seem like that. So this is just another right triangle that set up as a 45, 45, 90. So 4, 4, and then that makes the hypotenuse 4 squared root of 2. You can do special right triangle. You can do Pythagorean theorem. 4 squared plus 4 squared equals c squared. Excuse me. So you can do 4 squared plus 4 squared equals c squared. You could do trig again. I'm not going to go over because at this point they're just kind of repeating things. 14. Now this is different. I don't know. There might be one on the test. I don't know, but just in case, it's geometric mean. Right, that altitude is the geometric mean between the two parts of the hypotenuse. And so you see the proportion you set up, n over 6 equals 9 over n. You get there because this triangle, right, you can kind of turn over, and that would be the 6 over there and the N, and then the right triangle would stay as is, and you got N and 6. So you can see where the N over 6 equals 9 over N. Not 6 on the bottom there, 9. But you set up a proportion, cross multiply. Here's the answer in simplified radical. If there's a decimal, get a decimal, right? $15, I went further than I need to. Simply set up the trig. From 42, across is opposite. Important idea. Hypotenuse is longest. So the adjacent side will touch the angle, but it's not the hypotenuse, right? So that makes it where the x is. You need to find the x. You have a length for the hypotenuse. Adjacent to hypotenuse, check your blue chart if you don't remember. That's cosine. Cosine of 42 equals x over 38. $16, what is the measure of angle A to the nearest degree? So inverse trig, but you still set up opposite, across, adjacent, next to, hypotenuse, longest. We have an opposite adjacent length because we're looking for the angle now. So first you start tangent x equals 5 over 12, opposite over adjacent. To solve for an angle, you have to do the inverse. So you write tangent with a little -1, you put the fraction 5 over 12, and you type that into your calculator, right? So when you're looking for the angle, when you hit trig, you use the bottom row, tan with the little inverse -1. You lean a 20-foot ladder against the wall. The ladder makes an angle of 50 degrees with the ground. How far away from the wall is the base of the ladder? So you see the right triangle you set up there, 50-degree angle, 20-foot ladder. You're looking for the length on the ground. So from 50, you have opposite, adjacent, and that's hypotenuse, obviously. You're going to use hypotenuse and adjacent, which is cosine. Cosine 50 equals x over 20. Just multiply the 20 to both sides, right? Pretty straightforward. All right, 2 down, a few more to go. I might break this up after the next page. We'll see. All right, on to page 3. 18, an observer at the top of the tower spots a rock below at a 38-degree angle of depression. The tower is 25 meters high. How far away is the rock? So like we mentioned in the supplement for the final, angles of elevation normally do not show up in the right triangle that's set up on the ground. So you remember, angles of depression go from the line of sight, usually to the hypotenuse of the triangle that's formed. So there's 2 ways to approach it. What I did here is, even if you don't make this rectangle, but you identify the hypotenuse as a transversal line, then this angle down here in the corner of the triangle is the alternate interior, so it's also 38. So if you put it down here, then you can do opposite, adjacent, and of course hypotenuse. If you make it a rectangle, then you can put 25 on this side, x on the top, because opposite sides of a rectangle match. And then you still do opposite, adjacent, hypotenuse. Opposite and adjacent, that's tangent. This time you get 25 over x, which, if you want to do the 2-step process, is times x to both sides, and then cancel tan 38. That's how you get to this over here. 25 divided by the tangent of 38 is 32. Find the area of the triangle. Area of a triangle is 1/2 base times height. It's kind of hard to see what happened here, but I tried to separate the answer you get from the base and the height. But so the height is 24. 1/2 base times height, that's 24 to begin with. To find the base, which is right there, you're going to have to set up a trig problem. Opposite over adjacent, because opposite is 24, adjacent is x that we're looking for. Like the previous problem, you wind up with x on the bottom, so you'll wind up dividing with when you simplify it. 24 divided by tangent 61, and you get 13.3, and so 1/2 times base, 13.3 times height. In problems like this, if there's one like this, make sure to find the area after you get x. You know, a lot of times you'll get x, and even multiple choice, there's a good chance that, you know, like if this was a problem, you might have 13.3 on there just to throw you off, because you get that and you're like, oh, that's an answer. Find the area of a rectangle. Similar thing, except you have neither the base or the height. So given this angle of 64, let's see, you can set up opposite, adjacent, hypotenuse. The only thing you have is 81. So I set up one problem to find the base, which I labeled y, and one problem to find the height. Two separate problems, though, or I should say. So for the base, that's opposite and hypotenuse, which is sine. So, whoa, I don't know what just happened there. So sine 64 equals y over 81, and you solve that by multiplying the 81 to both sides. Then to go back and get the height, you do a separate problem. Don't use I've mentioned this before, but don't use the answer you just got unless you absolutely have to. The 81 is still there. You can do adjacent over hypotenuse as cosine. Cosine 64 equals x over 81. Multiply the 81. So base and height, and then you multiply them together, which you see up here on the top. All right. Well, on to number 21, and I totally did not just forget to record the last couple minutes of this thing and go through the rest of the page. Totally not. Anyways, the 4 points of a rectangle are A 3, 4, B 7, 4, C 7, -2, and D -3. What are the coordinates of points where AC intersects BD? In a rectangle, all right. In a rectangle, the diagonals will intersect each other in the middle. So I did miss. Sorry, I'm kind of near a window and a weird sounding bird outside. The midpoints of either AC or BD So, you find the midpoint formula, x1 plus x2 divided by 2, y1 plus y1 divided by 2. Simplify the fraction, and that point is where they should meet in the middle. Excuse me. All right, number 22, we realized later in the day that this example of the problem, because there is going to be a problem like this on the test, this example, A, there is a piece of information we should include to be more specific, and then B, the picture itself is just not drawn very well to scale. Quadrilateral ABCD is shown in the diagram. If BE is parallel to EF, what are the coordinates of F? We should have really also added, because it's similar to this on the test, that the top part, the top lines, AB is congruent to BE. The main idea of this problem, and all you really need to understand, is that you need to apply or find the slope, like from this D to C, and then replicate it to get from C to F and figure out where F is. Now, the problem kind of comes with where exactly is D located, because you see a line right here, but I don't feel like that goes to D. I kind of feel like D is maybe at -2, but then if you go up 2 to be on the y-axis, you should go up to here, and that clearly doesn't stop there, right? So I don't know if it was intended to be 1.5. I mean, that would split the difference, but it's not clearly shown. So I mean, I guess it's kind of shown at F, but it's left kind of ambiguous on the negative y coordinate. Either way, you should be going up 1 or 2 and over 7 to get either specifically at negative 9, 2 or negative 9, 1. Maybe negative 9, 1.5. The answer on the test, and then the one on the test will be a more accurate version. It'll have a definite answer, given the values on the graph. But that's the idea of the problem. 23, the diagram shows a rhombus. Determine if each statement is true or false. PMR is equal to 90. Yes, the diagonals intersect perpendicularly inside a rhombus, so that's true. PM does not equal MS. That's false, because PS gets cut in half. The two parts of it are equal. It's literally cut in half. PM does not equal MR. That's true, because the two diagonals are not necessarily the same length. So the half of PS will not be the same half as the half of QR. PR is parallel to QS. That's true because it's a parallelogram. It's from that family. 24, given rectangle EFGH, determine if each statement is true or false. DE is congruent to GF. That's true because it's a rectangle. DH is congruent to HF. Again, yes, like we talked about in the previous one. Diagonals are cut in half, so they're each half is the same, obviously. EG is congruent to FD. Yes, the diagonals themselves are congruent in length. Angle EFG is equal to 90. Yeah, it's a rectangle. So all of them are 90, and they're all true here. So that's that page. I think we're going to stop here for video 1, and then we'll move on to video 2. So if you watch this entire video, shout out to Isabella Ayala in 8th period, because she specifically asked for one. And if anyone else in 8th period is watching this, you remember the Annabelle doll from Friday. So that was fun. On to video 2.